And Shimon and I are going to talk about SBOM. We have many slides, but the time is limited, so let us give a quick pitch. The slide will be available online soon, so please check it later if you missed something. In this talk, we will explain the basics of SBOM and how we use it for vulnerability detection by overcoming some challenges. Let me explain what is SBOM, and before going to explain SBOM itself, I'd like to explain what BOM, B-O-M, means. It stands for Bill of Materials. A BOM is a list of the raw materials of a product. For example, let's imagine the food label. It contains a list of ingredients in a packaged food. And you can learn many things from that. For example, calories, expiration date, etc. The most important information is about allergies. Let's say you have a wheat allergy. Then you can avoid a risk by reading the food label. Let's apply this concept to software. SBOM, software bill of materials, is a list of components of a software application. It can be used for asset management, license management, and vulnerability management. Please remember the allergy analogy before. If you know a list of vulnerable components and you have a list of components you are using, an intersection of the two lists will be a list of vulnerable components you have. You should take care of it. This one is the most interesting subject for us, so we will explain how to use SBOM for vulnerability detection. Note that there are several SBOM standards, but I don't explain any of them in this talk. I believe the concept is more important than the standard. And our talk is, let's say, it's a vendor agnostic. So you can apply chips I will share with any standard. I have several challenges while using SBOM to detect vulnerabilities. So I'd like to explain common pitfalls and how to avoid them by using Python and Java as examples, because those two are the most common languages in our infrastructure. Let's go to pitfalls. The first case is Python. Generally speaking, SBOM is generated by passing a log file. A log file is a file that contains requirements of a product or application. The requirements.txt is the most traditional way to define requirements in Python. Note that it is allowed to set requirements without a version specifier. If there is no specifier, the latest version will be installed. This one is Poetry's log file. It uses TOML, TOML format to define requirements. And this one is pipenv. Pipenv uses pipfile.log. It uses JSON to define requirements. Anyway, you can get a list of components in a Python application by passing those log files. There are several pitfalls in Python. It is OK to omit a version in requirements.txt. Then it will be difficult to detect a vulnerability without a version information. Also, it depends on how you define requirements, but development dependency can be mixed up in a log file. Then it will increase false positives. The most painful problem is that it's very easy to come off the rail. For example, if you do pip install blah, 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 it will be untrackable because it is not listed in a log file. The next case study is Java. And pom.xml and gradle.log file are standard log files in Java ecosystem. Pom.xml is an XML file to define dependencies for Java project, which works along with Maven. And you can see the group ID, artifact ID, and the version are defined in the XML. Gradle.log file is a log file for Gradle. And you can see group ID, artifact ID, and the version are defined in plain text with several separators. The most common pitfall in Java is that missing log file. You can exclude pom.xml from build executable by setting add Maven descriptor as false. Gradle.log file is not included by default. Okay, then let's dig into how to avoid those pitfalls. In short, use runtime SBOM. It is the answer to overcome pitfalls. I believe that this concept is introduced by Jeff Williams. He is CTO at Contrast. And this is the original definition of runtime SBOM, but let me skip it. Roughly speaking, static SBOM is based on a log file. On the other hand, runtime SBOM is based on a running process. Why runtime SBOM is better than static SBOM? Static SBOM is, let's say, it's an unreliable narrator, and it may have false positives and false negatives because of the reasons I explained before. And runtime SBOM is more reliable because it comes from a running process. When it comes to a vulnerability detection, it means a lot. It means that vulnerability comes from runtime SBOM has a high exploitability because it's running. On the other hand, static SBOM is vulnerability comes from static SBOM is very unclear because there is no guarantee that it is deployed. Maybe it is not running. It is not running at all. So then, if so, there is no exploitability. Okay, let's see how to apply this concept to Python and Java. Python's module resolution looks complicated, but it doesn't. What we need to take care about is side packages, because third-party libraries go there. You can get a list of installed third-party libraries by inspecting site packages with the package resources library. Just for your information, it is not a SBOM tool, but OSQuery. OSQuery uses this approach to list up Python modules. So what we need is listing up Python processes and inspecting site packages used by them. Then we can create near runtime SBOM by that. I said near because there are huge drawbacks. For example, site packages may contain development dependencies, and also it's possible to set module paths. It's possible to set module paths dynamically. In that case, it's a bit difficult to track that. There are several approaches for creating runtime SBOM in Java. The first one is looking into file descriptor. You can get a list of jars used by Java process by looking into file descriptor used by the process. But there is a problem with that approach, which is known as FAT or uberjar. Let's say it's an all-in-one package. Everything is packaged into a single file. So the file descriptor-based approach does not work with FAT or uberjar. To solve this issue, we can use a tool called JBOM. It attaches byte body agent to a running Java process and gets classes used by the process. So you can get runtime SBOM with this tool. And I explained only 2 examples, Python and Java, but you can apply this way of thinking to any language. Starting from a process is a key factor to create meaningful SBOM.
Thank you, Niseki, for your part. And here from now on, I will take over. So great, we now know how to collect SBOMs, but what should we do now? Well, we have to do the actual heavy lifting to actually collect the SBOMs. And how do we do that? Or to be more precise, how do we do that at Line? At Line, we started a project called Shisa, which then later turned into a product that we use daily at Line. So the name Shisa comes from a cultural artifact that can be seen at rooftops or entrances of Japanese buildings, warding and keeping evil out and good spirits in. You can see a picture here of a Shisa statue standing here on the right. So what is this other Shisa that we created? Well, it's scanning our infrastructure daily for security concern, and then reporting its findings through a dashboard. And this dashboard is not only available to security personnel, but also other personnel like developers, server administrators, and other persons in the company that's concerned about the security stance of their servers. So basically, Shisa helps us reducing vulnerabilities, keeping the evil out, and fortify Line's infrastructure, keeping the good in. Exactly the same as the mythical creature Shisa. So this is where we utilize the SBOM concept. So how does this Shisa work? Well, here is a simplified picture of the Shisa data pipeline. So it first starts off with running a script on all of our servers. This collecting data, not only SBOM data, but other critical information for determining the security stance of the server. It then outputs a JSON file, which we call a report. These reports get sent to something we call the Shisa Pipeline. Here, the report gets enhanced by various external resources. For example, is the IP on the server exposed through any load balancers? Or who is the owner of the server and what service does it belong to? And one other part that we enhance the report with is something called the OSV. The OSV stands for Open Source Vulnerabilities. And there is a publicly available database that we use to map vulnerabilities with the SBOM information that we collect. The enhanced report is then stored in something we call the report database. Then we use this database to display the data for our employees at the company through something we call the Shisa dashboard, which is basically a web UI. It also provides an API, so it can be integrated with other services. So now I want to talk a little bit about each of these components. So starting off with the Shisa script. At Line, we have over 150,000 servers running at multiple data centers across multiple countries. Shisa runs at these servers every day, at least once. You can also make on-demand scans, so it's basically readily available 365 days a year. Shisa is built with Python and supports any Python interpreter from 2.6. And you may ask why we support Python 2.6 and 2.7 that has already went end of life. But this is because some of our servers still supports older operating system, like CentOS 6 that has a default Python interpreter as 2.6. And the information that the Shisa script collects is not only limited to the SBOM, but it also collects information about interfaces, what kind of ports are being open on the servers, process information, application information. We also have hard-coded vulnerability checks that we write, and also hardening checks for open source middleware like Nginx, Apache HTTPD, and Linux kernel settings, and more. So after the Shisa script generates the report, it sends it to the next stage, which would be the Shisa pipeline. So at the pipeline, we ask us the question, is there any information that's not available at the server? And is it really enough with just this information? So for example, we would like to know who is the owner of the server and what service does the server belong to. This is because if you find some vulnerability that has high priority, we would like to fix these as soon as possible. Without knowing the owner, it's very hard to track down and fix the vulnerability. But knowing this, we could easily contact the developer and fix the problem right away. We would also like to know the service, because if the server belongs to something really critical, like our main service line Messenger, or just some internal services that can be fixed at a later stage. And something that's also good to know is if the server is directly exposed to the internet, and if so, what ports it is being exposed on. This is also information that we gather at the Shisa pipeline. And finally, if we were able to use the SBOMs to find vulnerabilities, that would be really great. So we tried to find a way to do that as well. And how does the Shisa pipeline look like? Well, here is a very simplified picture. We get the reports from the script in here, and then we start to enhance the report with various external resources, like if the server is exposed to the internet, who is the owners, and the open source vulnerability information. This enhanced report is then saved to a database. In our case, we use Elasticsearch because it's very convenient. And then the report from the saved at the DB is then displayed at the dashboard. But before talking about the dashboard, I would like to talk a bit about one of these external services, and that is the OSV information, because this is very tightly related to the SBOM that we are talking about today. So what is OSV? Well, OSV is authored by 2 employees at Google, and it's the standardized format for open source vulnerabilities. Basically, it matches an ecosystem with multiple packets, and each version of these packets against vulnerabilities. So we can find out what vulnerabilities is affecting what kind of versions of packets. And there is a freely available database of this at osv.dev. And it basically works by aggregating various adversary feeds into a big database, which then can be downloaded. You can find more information about how it works at the GitHub page mentioned at this slide. So how do we use this database at Shisa? Well, if you were to request directly to the OSV database, then we would require over 150,000 requests each day. And that would probably just block us because of rate limitations. So instead, we download this database to a local Elasticsearch cluster. And from there, we retrieve the data. So when the Shisa pipeline gets in a report, it extracts the SBOM information and queries that to an API. This API then queries the database and get back the vulnerabilities that is affecting the SBOM. And then that information is then handed back to the Shisa pipeline, which enhances the report. So how does this, how do we join SBOM with the OSV? So here is 2 schemas. On the left-hand side, we have the OSV schema, and on the right side, we have our version of an SBOM. So we can see here that in the OSV, we have something called an ecosystem, which match up with what we call a type. This would be, for example, PyPy, Maven, or Go. And then we have a name, which would be the name of the library. In Python, we have, for example, requests. And then in the OSV schema, we have a list of versions compared to the components where we have 1 version. So basically here, we try to find if the version is inside the versions list. And if that is, we have found a match, and we can be quite sure that our package or component is vulnerable to this vulnerability. So this is about OSV. So next up, I will start to talk about the dashboard. So on the right-hand side here, we can see a screenshot of the dashboard. The dashboard has multiple purposes, but one of the biggest purposes is to provide transparency to different stakeholders within the company. So we can see here that we have a few vulnerabilities on the server. And on the left side of the screenshot, we can see a list of different components that we are gathering. For example, what processes and applications are being run at the server, and what ports are being opened, and if any of these ports are directly exposed to the internet. We also have the components, which is basically the SBOM components. You can see here we have 340 of them. And then we have vulnerabilities and something we call enhancements. Enhancements is basically items that does not comply with our hardening checks. So users can use this page also to search with losing queries. For example, we can search for all servers that belongs to the line messenger service and has ports open to the internet and find vulnerabilities in all of these servers. And lastly, we also have implemented a gamification function where you can assign vulnerability tasks to yourself, go into the server and fix these vulnerabilities. And then after that, rescanning the servers. And if it's validated that the vulnerabilities has been fixed, you can gain points which accumulates and then get displayed at the dashboard. I think not many people is using this function at the moment, but it can serve to some extent as an incentive to try to fix vulnerabilities. So this is all the parts explained. So before wrapping up this session, I would like to talk about 2 use cases which we use Shisa in. So use case 1 is when we release a service at line, we always have to go through a security risk assessment. So before Shisa, we were doing this semi-manually, but logging into the server, running a script, and extracting a CSV document, which we then passed on to the developers. And this was basically just done one time before releases. So it lacked like a lot of things. So after the release, we couldn't check if there was some change and there was any new vulnerabilities. And we also had to like give this CSV document to the developers, and they had to pass it back, and we had to check the server manually again. So it was really troublesome. But after Shisa, this was done fully automatically every day. So we don't have to pass any Excel documents. They can look at the Shisa dashboard right away. And this is done every day on demand. So even after the product is released, we can automatically see what kind of vulnerabilities and if there is any enhancements that need to be done on the server, we can see it directly. And this is accessible 365 days a year. And the second use case is sometimes we need to provide information, for example, to financial institutions on what vulnerabilities are affecting our servers with highly classed information. So before, we looked through vulnerability feeds, and we developed hard-code vulnerability checks to check these problems. But this was also a manual execution. But after, we now increased our vulnerability coverage from around 30 hard-coded vulnerability checks to around more than 8,000 vulnerability checks through the OSV database. And this is also done automatically and also on demand. Hard-coded checks is still done because in some case we need more intricate conditions, like not only checking the version, but checking some other settings as well to make sure that it's actually a vulnerability. So this is for the use case, and now I would like to wrap up this session. So SBOMs helps us with transparency of what a software process contains, but it has its pitfalls. So log files can come without versions. We are not ought to enter versions. And components installed outside of log files is also a big problem. And in some languages, it's not even mandatory to use log files. And then to fix this problem, we can use something called runtime SBOM, which mitigate the issue of using log files and instead getting the SBOM directly from the processes by, for example, reading the file descriptors. And then we're able to boost our vulnerability detection by combining SBOMs with the OSV database from around 30 to over 8,000 vulnerabilities being checked. And finally, openly providing data to not only security personnel, but developers, server administrators, and other personnel inside the company helps us in addressing security concerns more quickly because everyone can work as one team. So this is everything for us. Thank you so much for listening.
Niseki-san, Vestin-san, ありがとうございます。
Thank you very much, Seaman, and also Niseki-san. So we have plus talk here from now on. We would like to deep dive into the session with the interviewer. We also would like to select question that has been posted through the viewers as much as possible. Those of you who have question, please press the question button in order to post your questions. So we'd like to invite Mr. Takeshi Takizawa from Yahoo Japan. Thank you very much. My name is Takizawa from Yahoo Japan. Thank you very much. for today. Thank you very much. So, Mr. Takizawa, can you briefly introduce yourself, please? Yes, I am from Yahoo Japan, and I'm in charge of security overall, security and development, and also responsible for system management group. Thank you very much, Takizawa-san. So without further ado, listening to the session, is there any questions or clarification that you'd like to get from two speakers? There are two things. One of them is, so in terms of the vulnerability of the SBOM, in runtime SBOM, it was a lot of learning. And within that, in terms of looking at the internet articles, the development processes in terms of the approach, as much as possible, you need to bring it forward in order to be prepared for the security. So that's so-called the notion of shift left. And on the other hand, the runtime SBOM, it's the sort of the security vulnerability towards the right in terms of when you are going to find and detect the vulnerability. So SBOM as a keyword, SCA tool, software component analysis, I believe. Those are the two, SCA. And that also is recommended to utilize on the early stage, in other words, the left side of the processes. And having said that, shift left, this way of thinking, and SCA tool, and this runtime SBOM, I would like to sort of sort out how best you will be able to utilize these three approaches in getting a very secure security approach for the developers. So the approach and what can be done, I would like to get advice from you on this end.
And I think the shift left is very important. I agree with that, but I also think we have to take care of right side, because I said in my presentation, I said that runtime SBOM is more meaningful than static SBOM because it is running. So we have to take care both cases.
Yeah, I totally agree with Niseki-san as well. It's important to look at the left side and inform developers and people actually coding and programming about like how to deal with vulnerabilities in an early stage. But it's also very important to do it, like even if you look at the Git repository and you can see some log files and you can see they are vulnerable to something, but we cannot be 100% sure that this is the code actually deployed at the server. So we need to look at like real-time data. That's why we use the runtime SBOM. But I get your point as well that like looking at the left side is really important. That's why also that we have with the Shisa project, we now scan it every day. So if, for example, if we use CI and CD tools, which automatically deploy, so when you push something to GitHub, it automatically deploys on the server, and then you can automatically see that at the Shisa dashboard. This means like even at the development stage, at the early phases, before releasing something to the public, you can see at development server what kind of vulnerabilities and enhancement that needs to be done to the application to, well, meet up with our standards. So I think looking at the dashboard at an early stage is something that can help something at the left side, I think. And also for enhancements or hardening tasks, we have guidelines within the company that you can check and look up to, try to fix the problem like before deploying into the real environments. Yeah.
開発のプロセスを考えたとき。
So when you think of the development process, the things that you can see in the early stage, and then to the end, you have to also make sure once again, you need to cover both. You have to work on both of that so that we can deal with the security issue. That is an important concept. I understand. Another question that I have is that you have this Shisa. You use this product, and you now be able to see vulnerabilities. CVS score, there is high score down to lower score. There are so many vulnerabilities that you would discover, and then you have to ask developers to fix them. How do you communicate better with developers so that you can motivate developers to try to fix some of those vulnerabilities? Any thought on this? Any actions you take?
So there is a lot of things like we have another team that looks at this and see if there is some critical vulnerability. They assess this vulnerability and see how critical it is. If it's really critical, we make a wide company announcement to all developers that they need to fix this problem fast. And like, if there is a few servers, we contact the developers personally. But sometimes we have to like tell them like separately. But we can use this Shisa dashboard to at least display what kind of vulnerabilities is affecting their server. They might not know, like, do I need to fix this one or do I fix this one? But at least they can see the vulnerabilities, and then they can like ask our security department, what is the recommendations that you think that we should fix? And we don't have a really tight guideline of like if the CSV score is above 8 or something like that, you need to fix the vulnerability. It's kind of like by case-by-case basis, I think, in the company right now. So, yeah.
So you're able to visualize vulnerabilities. If there is critical vulnerabilities, the top management may send out a message throughout the company to try to fix that. The lowest score row vulnerability, each department, each team can deal with that. That's possible because you have been able to visualize the vulnerabilities.
Relative to that, this is my last question. So developers, how would you motivate them? How would you motivate developers to do their work? I think is another important initiative. So do you have any ideas of motivating the developers? And if you have done a good sort of way of doing it, if you have not done yet, do you have any ideas how you'll be able to introduce those ideas? I would like to get a hint from you.
I will answer that question as well. So I mentioned in my slides also that in the Shisa dashboard, we have a kind of gamification part. Actually, this is not used so much, but that's basically our fault because we haven't promoted it so much. But what we think is like if we give some incentive, for example, if we have high-risk vulnerabilities on a server and someone goes in and fixes this, like apart from the security department, like developers actively look at this and fix the vulnerabilities, they can get points, which then accumulates, and then we could have like a high score list. And then there is like, they could get like, I don't know, some shopping cards or like higher salary or something like that. That's not for art to decide, but they could get something like to get them motivated, I think. Or even like if they can show that to their department leaders or something, that actually our team is actively working against fixing vulnerabilities, I think that could be a good incentive for developers and other members to actually fix vulnerabilities. Because usually, I think for developers, they have a lot of to do, like to fix the product and bugs and things like that. And yeah, sometimes, yeah, maybe security comes second hand, but we want to try to make that like a part of the development process as well, I think, yeah.
It's very true. The Shisa as a features and function, the gamification, the scoring, and utilizing the score. This individual is accumulating higher score points. So maybe not high point, but many issues in terms of the number of issues. If you can visualize that, then you can utilize that effectively so the seniors or manager can evaluate that individual, or company as a whole maybe can recognize that person by form of a reward. So that's going to be a motivation on the part of the developers for sure. So they will be looking into security issue with more interest. Yes. Well, thank you. It's a very important issue. and very important content, a lot of insights. So the insight that you provided to us, I would like to bring that back home to my company. So leveraging that, we would like to make sure that security level is hard and secure. So thank you very much for today. Thank you.